in class today we talked about section 1.7 and started on 1.8 with statements of logic. Let's just review some of the things that we said in class today. Remember we had those 4 vocabulary words: the statement, the converse, the inverse, and the contrapositive. When we think about that statement, we said that it was going to be if P then Q, right? Our statement, left to right statement. And then our converse happens when we switch the hypothesis and the conclusion. So if Q, then P. The inverse, right, go back to our statement, happens when we do the negation. If not P, then not Q. And the contrapositive, if not Q, then not P. So they get negated and swapped. Notice the notation. P implies Q for the statement. Q implies P for the converse. Not P implies not Q for the inverse. And the contrapositive, not Q, implies not P. So it's notation that we're looking at there, right? The little tilde mark meaning not, and the arrow that means implies. We talked also today, well, in class, about the fact that if the statement is true, then the contrapositive is also true. And when we write that with this notation, it looks like this. If P implies Q, then it's logically equivalent, that double arrow means logically equivalent, that not Q implies not P. What logically equivalent tells us is that if we have a statement, that we can negate and switch our hypothesis and conclusion if it's more useful to us in that format. What am I talking about? I'm talking about a problem when we start getting into the chain rule. Let's talk about the chain rule, and then we'll talk about that logically equivalent and what it does for us. So the chain rule says that if P implies Q and Q implies R, then P implies R. So watch the red statements down the edge as we go through this example. If you study hard, then you'll earn a good grade. Seems pretty, right? If you do this, then that happens. If you earn a good grade, then your family will be proud. Again, it makes sense. So then, your final statement, right? What can you conclude? What can you use the chain rule to say? Well, if you study hard, then your family will be proud. So if P implies Q and Q implies R, then, or therefore, P implies R is what we're allowed to say. It's kind of strange, I know. But let's look at one, because again, these are going to be word problems. We need to figure out how this works before we start applying it to geometry. So let's go ahead and do this crazy one. It's actually out of your book. Let me make it a little bit bigger for you. No, not like that. That's okay. If gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. And if trolls tell tales, then elves don't eat earthworms. So pause the video, take a second, and write those statements down. But I'm going to move ahead because I already have them written. And I'm going to start with, well, let's translate this. Let's just go ahead and use G for gremlins, E for elves, T for trolls, and W for wizards. And just translate our statements. So if gremlins grow grapes, then, or implies, elves are going to eat earthworms. The second statement tells me if trolls don't tell tales, so if not T, right, we have that negation in there, implies, then wizards weave willows. There is not, it's not a negative, right, it's just a W there. If trolls tell tales, so that one's a positive, then elves don't eat earthworms. And when we look at these, notice that they're not as in order as they were in our last example, right? We kind of have to figure out how to put these together so that we would have a statement that works. So when we think about that, we want to look at, okay, which ones are the odd man out, right? Who doesn't have a partner in this game? Because we want to be able to connect it so that we have a zigzag So we can say the beginning and the end. So when we look at this, hopefully you're seeing that the odd man out, or the ones that don't have a partner, are G and W. So then after we've identified that, then we just say, okay, well the first thing I want to do is I want to do some reorganizing. I can reorganize in two ways. The first is I can shift the order the statements are in. And the second is that I can use the contrapositive to rewrite the statement somehow logically equivalent. Right? Use that logically equivalent statement to get what we needed. So in this problem, since G started there, let's go ahead and leave it. So G implies E, or gremlins imply that the elves are going to eat earthworms. Well, then it makes sense that the next thing that we would want, oh, I missed a not in there, didn't I? My statement. Then elves don't eat earthworms. I missed a not right here. Right? Trolls tell tales implies that elves don't eat earthworms. So if I have an E that's positive here, then that's the next thing I want to be able to talk about. So I'm going to use this statement and make a logically equivalent, right? Logically equivalent statement that, right, negate and switch. So it went from negative to positive, implies go from positive to negative, or not it. So I switched my order, and I used a contrapositive, and now my trail continues, right? Not T, I have not T. Not T implies W. So my therefore statement, right? I've got all the connections, got all my connections, right? If I start at G, I go from E to not T to W. So my beginning, so my therefore, my beginning implies my end. I need a statement though, you can't just use the shorthand. So my statement would be that if gremlins grow grapes, then wizards weave willows. If gremlins grow grapes, then wizards weave willows. My chain rule is what got me there. This is the chain rule, that they made a chain of information so that I could say the beginning and the end are implied, or the beginning implies the end. I've got a practice problem for you. It says, if the line is long, then Eileen will go home. If it is morning, then Eileen will not go home. If the line is long, then it is morning. Write them down, come up with your statements, use the chain rule, and then come back and check your work. So here's the solution to this problem. And hopefully you got the chain rule to work, but hopefully it also felt really awkward to you when you were getting it to work. That your statement should be, or your conclusion should be, therefore, long lines imply not long lines. Well, what this tells us is that somewhere one of these pieces of information has to be true, because long lines can imply that there are not long lines. So we have that contradiction happening. So our conclusion should be that something in the given information is false, because something doesn't work. But my real concern is, did you get the chain rule so that you got to this answer? Hopefully you did, and your homework is accurate on your calendar. I will see you in class on Thursday, or whatever day it comes up. Bye.